Indiana University East School of Natural Sciences and Mathematics. Specific heat and heat capacity. So it can be shown that the change in temperature of something is related to the heat evolved by Q is equal to the heat capacity times the change in temperature. Now the heat capacity here has units as joules, typically expressed in joules per degree Celsius, which is sometimes expressed as joules per Kelvin, which is the same thing. Now, you should be aware, however, of a couple of things. Number one, the heat capacity, because the amount of energy required to heat something up is proportional to the amount of stuff you have. The heat capacity is an extensive property and depends on the amount of substance that you're trying to heat up. The second thing to realize is that Q is of the actual system is equal to minus Q of surroundings. So typically if the temperature is increased, the temperature of the surroundings is increased, then your even though Q is going to be greater, so your temperature increases, so your Q is positive, because that's of the surroundings, that heat has to come from the system, and therefore the Q system is going to be negative. It is exothermic, and vice versa. An example of an endothermic reaction is if you have a cold pack. You crush the cold pack, you squeeze it, it feels cold. That process is endothermic, and it, it leads to a decrease in temperature. The surroundings loses heat, that's your hand, but the system, the reacting mixture itself, the heat has gone into that, and so that is endothermic. Q is positive. We, however, quite often report the specific heat capacity, also known as the specific heat of a substance, and it is related to the heat capacity by, basically it's the heat capacity per gram, and typically the units of this would be joules per gram per degree Celsius. And from this you can show that the Q, the heat evolved, the heat change is mass times the specific heat times the change in temperature, where the mass is in grams, the specific heat is joules per gram per degree Celsius, and the change in temperature has to be in degrees Celsius, which is equal to the change in kelvins. Let's take an example of this. We're going to assume that coffee has a specific heat of 4.184 joules per gram per degree Celsius, and so this is a specific heat. Note that different books have slightly different symbols for specific heat. And here is the mass of coffee, and we have, note that we are using mass, not volume. If you're given a volume, you will need to use the density to figure out the mass. And we need to figure out the change in temperature. So the change in temperature is the final temperature minus the initial temperature, which is 95.6 degrees C minus 20.5 degrees C, so that's 75.6 0.1 degrees Celsius. Therefore, the heat required is mass times specific heat times the change in temperature, which is 2.50 times 10 to the 2 grams. That's the mass I've got here, times the specific heat, which is 4.184 joules per gram per degree Celsius, times 75.1 degrees Celsius. If I go through and cancel out my units, I find I have the energy in joules, which is what I want, and it comes to 7.85 times 10 to the 4 joules.